QUIC, QUIC, or QUIC UDP Internet Connections. This protocol is often referred as HTTP version 3, and actually it has been registered as HTTP version 3. Nowadays, more and more browsers are trying to, and more web applications, as a matter of fact, are trying to switch to HTTP version 3, aka QUIC protocol. Let's review in this video what makes QUIC protocol so special and why it is different from HTTP version 1.1 and HTTP version 2. This video will build on the fundamental knowledge of what HTTP protocol is and what it does. So if you are not aware of it, please check out my video about HTTP. And let's start reviewing why QUIC is so special and what are its selling points. Well, to start with, we already reviewed the full name of the abbreviation. It's QUIC UDP Internet Connections. Just from the name, we can deduct a couple of things, right? We can deduct that QUIC is using UDP instead of TCP. This is a very big change, right? It's similar to petrol vehicle that is using petrol and electric vehicle that is operating by recharging the battery. So it's using a completely different charging mechanism and charging substance. It uses UDP as opposed to TCP used by HTTP version 2. HTTP version 2 managed to improve. It managed to have a multi-stream connection, it managed to have faster connections, and etc. But still it's using TCP. QUIC leverages the strengths of UDP and it closes the gaps associated with the disadvantages of UDP. So the main change occurs on transport layer. Check out my video about OSI model if you don't know what a transport layer is, where the UDP operates, UDP versus TCP. So on the transport layer, UDP, as opposed to TCP, it doesn't require a handshake. This is a very basic knowledge about UDP. So it just sends the connection and it doesn't care whether the connection has reached the way it was going or not. So these are the disadvantages of UDP, but UDP has been utilized for years by media companies, by even YouTube or video calls, audio calls, where they don't quite matter if some of the packets are lost. They don't try to retransmit them or track them so that they reduce the amount of overhead and time required for the connection. That's why UDP is often referred as an unreliable protocol. It's not secure, it's not reliable. So looking at QUIC and thinking how amazing it is can be quite shocking for some people. UDP is secure and reliable, and it has reduced latency and improved performance. So reduced latency and improved performance is the qualities of UDP that we have, and the QUIC protocol differs from UDP because it became secure and reliable in connections. It has encryption, it has the flow control in order to make sure that the packets reach the addressor. However, it doesn't have the three-way handshake, so it doesn't have this overhead associated with TCP. So by doing this, it addresses the TCP disadvantages. It has already been registered with IETF as HTTP version 3, although it's still referred as QUIC because this is the underlying protocol. Don't forget that QUIC operates on layer 7, so it leverages layer 3 of UDP, right? But still it operates on layer 7, just like HTTP. That's why it's HTTP version 3. And it prides itself in having 0 RTT. RTT is a round trip time. RTT, round trip time. So RTT is a time needed for one connection to be established and for data packets to be sent over during this connection. So one established connection and the data packet exchange is called RTT, round trip time. So I hope this is clear. How QUIC achieves the security? So it says we're saying that it's a secure protocol. So it uses TLS. TLS handshake is still there. The minimum version of TLS that it accepts is 1.3, so it doesn't accept any lower versions of TLS, making sure that it's the sort of more or less latest version, and it can be considered as secure. And it allows multiple streams of data to be sent over one connection. We will review it on the diagram shortly. And it has congestion control. Honestly, TCP has congestion control too, so that's not sort of something that HTTP version 2 doesn't provide. However, knowing that it uses UDP, the ability of it to provide congestion control is very important. What congestion control does? Imagine you're on your browser and you're trying to access google.com, right? Your browser speed is very low and the speed of the web server of Google is very high. So Google might start sending you data that you're asking for, but your browser, your internet connection might not be able to accept this data at the same speed. Imagine that you're on the road and there are 4 lanes of cars and there is only 1 lane that goes into motorway. So what will happen? There will be a bottleneck. It will get narrower and cars will be in a traffic jam in order to get to the motorway. And similar thing happens here when there is no congestion control. And it's very hard then for the browser to get all the packets intact. It can obviously even make your internet connection even slower. That's why TCP had congestion control forever, basically. And it controls so that the connection, the speed between the web server and web browser is adjusted to the optimal speed so that the receiver receives the packets on the speed that it would like to receive. QUIC offers congestion control too, which is again a very important achievement for a UDP-based protocol, because UDP innately doesn't offer this feature. It prides itself in being the connectionless, in being the not tracking anything, not having this overhead. At the moment, 10% of traffic is using HTTP. You like to ask me where I take the sources for my statistics. Well, there has been different numerical statistics available on the internet. Some would say that 9% of the traffic is HTTP version 3. Some would say that 15% of the traffic. Some would say that 12%. 10% is the average figure that is available among different statistics on the internet. So on average, 10% of traffic is using QUIC protocol. Let's now review on a diagram basis, because I imagine I threw at you a lot of advantages of QUIC without actually reviewing what they mean. So QUIC prides itself. What are the selling points of the QUIC mainly? It's multi-stream first, and it has 0 RTT, round trip time, second. So there are 2 key selling points of QUIC. Otherwise, it wouldn't be needed by internet community. Multi-stream, what it means? So imagine TCP between the user, right? User and browser. On a very high level, TCP has 3-way handshake, right? In order to establish the connection. This is TCP. UDP doesn't have the 3-way handshake. It just sends the information, right? And it doesn't have to be sure that the information reached the party to whom it was addressed to. So this functionality of UDP is utilized for multi-stream. So imagine you're a client, you're a user, and you're trying to access the web server. When you're trying to access web server is sending you data, right? And we already talked about it. One web page has different components of it. It has a HTML web page with the data information, right? It also has different other components. It has images, right? On the different web pages, you can see images that are passed from the web server. It has different scripts, might have, etc., etc. If you inspect the web page that you are seeing in front of you, you will see a list of different components that it contains. That's why the web server is sending a list of different components that make up a whole web page that is human readable by you. So you see the end product, you see the web page, but this web page consists of different parameters, different components. When we say it's multi-stream, on each connection set with the client, it sends several components of web page. On each stream, several components are passed so that it's faster. It can initiate several streams at once, and it can send HTML page here, image 1, right? Image 2. Then the web page has videos, video 1, script, And it can send all of these elements of a web page by initiating, for example, as in this case, 3 connections, and send several components over each connection, making sure that the user, the client, gets the components of the web page in an optimal amount of time without having to establish the 3-way handshake and without having to sort of keep the connection open to send all of these components. It just keeps sending them through multi-stream. This is the multi-stream functionality, and it is different from HTTP version 2 and HTTP version 1.1 because again, it's not built on TCP. It doesn't have to establish TCP connection. So how would it happen on the high level traditionally? We'll first establish TCP connection, then there would be TLS handshake, and then we would start sending the components, right? However, here we don't need this first hop. We don't need the 3-way connection. And then you might ask, okay, we don't need the connection, right? But we still have to establish TLS handshake. What happened to a TLS handshake? By the way, if you need more information about TLS handshake, don't forget to check my video about TLS handshake. That's a valid question, very valid question. That's the question I asked when I was researching the QUIC. And it brings us to its second selling point. Second selling point of this protocol is that it has 0 RTT. That's how it's marketed, right? But that's not always the case. So marketers like to have these catchy phrases, mottos, in order to sell the product, in this case the protocol. Yes, even IT protocols probably have marketing campaigns around them. However, it's not always true. I agree. QUIC is still faster. It's still faster than HTTP, version 2. However, it doesn't necessarily have 0 RTT. When the connection is first established, it still needs to have TLS handshake, right? It still needs to establish the connection. Therefore, the first connection is around 100 milliseconds of RTT when the connection is established as first. 100 milliseconds is really nothing in terms of the human definitions. However, it's still time, right? It's not 0, basically. However, once the first connection has been established, the time to establish next connections is basically 0. So 0 RTT, 0 milliseconds for repeat connections. When the connection is established between the server and the user, imagine that this is the first connection. We do the TLS handshake at this point. The connection is established, TLS handshake, then the multi-stream is used, multi-stream is used to pass all this data to the client. And obviously, if client has some data to send, the repeat connection will not have to have TLS. So it will have 0 round trip time, 0 RTT, because it doesn't have to have the TLS connection again, and it can reuse the connection to send back the information that it needs to send. This was a short overview of QUIC protocol. If you have any questions, please leave them in the comment section down below. Please help me to satisfy the YouTube algorithm. Don't forget to like this video and subscribe to my channel so that this specific and mysterious algorithm likes my channel and shows it to more viewers. Thank you for being with me today and have a nice day. Bye!